Hi there, and welcome to Excellent Link Academy. Let's dive into solving this particular question in mathematical induction. First, going says prove by mathematical induction that 1 over 1.2 plus 1 over 2.3 plus 1 over 3.4 plus 1 over 4.5 plus plus 1 over n into n plus 1 equal to n over n plus 1. Check out our introduction to mathematical induction. So I've done an introduction to mathematical induction whereby I said that when it comes to induction, there are 3 steps there. The first step is called the basic step, second step is called the induction step, and the third step is called to let n to be k plus 1. So last class on induction we said there are 3 steps. That step 1 is to let n to be what? 1. Step 2, let n to be what? K plus 1. And step 3, let n to be what? N to be k, so k plus 1. So we said when it comes to mathematical induction, the topic is all about you proving. So it's the ability of you to prove mathematical statements. And we said there are 3 rules there. The first rule is called the basic step, which is what? Let n to be 1. Second rule is called the induction step, so let n to be k. And the final rule is called the let n to be what? K plus 1. Let's now use this rule to solve this problem. So solution, please. Solution, please. If I see any question under induction, what comes to mind first? What's the first rule? Let n to be 1. So it means my first rule, let n to be what? Equal to 1. Now here's the concept here. For this equation, I can obviously see my left hand side and right hand side. Alright, look up please. This part here is my right hand side. This is my left hand side. So from here to here, right? From here to this point here is my left hand side. Why this part here is what? My right hand side. Focus on the 2. Pick out the left hand side first, please. For your left hand side first, observe that I'm having all this one are just letters, right? But I'm after n to be 1. So the only one that has n, or perhaps the only expression that contains n in the left hand side is what? Just this, Abi. So repeat this down. For left hand side, I have what? 1 over what? N into what? N plus. So as I was saying, I said your first task is to follow your first step, n to be 1. And if n is 1, what do we mean? Of course, focus on your left hand side. So you have to use my left hand side. The only expression that contains n is just this. Pick out this. I have it here. We said put n as 1. So this becomes 1 over, this is n as 1. That becomes 1 into 1 plus 1. Of course, if I observe here, I should have 1 over 2 as my answer. How? 1, observe 1 plus 1 is 2. 2 times 1 is 2. So my left hand side, this one gives me what? 1 over 2. Let's observe right hand side, please. For right hand side, what do we get? I'm having what? N into what there? N plus 1. We said the task is to put n as 1. We are still in the first rule, first step. Alright, put n as 1. I'll have 1 over what? 1 plus 1. Please give value here. I'll have 1 over 2. That's all. Right? So observe that my left hand side is equal to what? Right hand side. So my first step is done. Let's now assume that your first step, observe that, let's say for instance, your left hand side is 1 over 3, right is 1 over 2. They are not the same. So if they are not the same, definitely you will not proceed to the what? Second and third step. But since they are the same now, you have to proceed to what? Second step. Please, what is second step, please? Let n to be what? K. To be equal to what? K. Please, if n is k, it means that anywhere I see n in this question, I'll put what? I'll put k. As easy as that, please. Alright. Is it recorded? Check. Alright. From me now, what do I get here? I'll have from here 1 over what? 1.2 plus 1 over what? 2.3 plus 1 over what? 3.4 plus 1 over what? 4.5 plus plus this is one. Observe, we said anywhere you see n, put what there?
K.
Put k. So for me, I'll have 1 is 1 over this is what? K. So put k. So that becomes k into what? K plus 1 equal to k over what there? K plus 1. All right. Now listen up, please. Here's the concept. We said when it comes to n to the k plus 1, if you are in my previous class, because I believe you have watched my initial videos on this. I'm not trying to just for those that are just joining our class, just trying to break it down. I've done the introduction already, so I'm not trying to repeat what I said initially.
Okay.
For n to be k, listen up. The first rule was n to be 1, which we have done and confirmed as true. Second step, n to be k. If n is k, here's the concept. It means that it is not. Look, observe this equation. If I'm to ask a question, is this equation the same thing? Are they the same thing?
No.
Is the left hand side and right hand side the same thing? They're not the same thing. So usually, the second step, you will always assume it to be true. You always assume that second step is true, right?
Yes.
So it's not true, but we assume to be true. That's the second step. Just put n as what? As k in the question. You are done. What's your third step, please? Third step, please. Let what? N to be what? K plus 1. Now listen. At this point is bloody. Students find n to k plus 1. They find n to be equal to k plus 1 difficult. Why? Because they are not good at simplifying. So your task now is that your ability to overcome this third step is how familiar are you with mathematics? Look up, please. From when I look up, we said put n as k plus 1. That does not mean that you should repeat this question and put n as k plus 1 is wrong. First task when it comes to n to be k plus 1 is that you have to repeat your assumption equation first. That is, I'll repeat from here to here down first. That becomes 1 over what? 1.2. Next up, plus 1 over what? 2.3 plus 1 over what? 3.4 plus 1 over 4.5 plus plus 1 over what? K into k plus 1. All right. We said when it comes to k plus 1, repeat your assumption equation first down. When you are done, go back to your original question. From here down here, n start from where? Of course from here. So have what? Plus. This plus becomes your plus sign here. Are you seeing that? This is 1 over. This n is what? K plus 1. I'll have k plus 1. Observe. This one becomes, this n becomes k plus 1. Then this plus 1, I have it here. Mind you, I'm not done yet. Right? I'm having equal to, let me put the equal to here for space sake. The equal to meant to be here, but no space. So I have equal to, n is what? K plus 1 over what? N is what? K plus 1. I can see plus 1 here. Put what? A plus 1. Listen up. Let me go back again. I say when it comes to k plus 1, it's easy. First task is what? Repeat your assumption equation down first, right? When you are done repeating, go back to your question. Where the n starts from? Plus, this is a plus here. 1, this is the 1 here. All over, this is all over. This n itself is k plus 1. Open bracket, this n is what? K plus 1 plus this 1. Next up, equal to, this n here is k plus 1 here. All over, this n is k plus 1. Next up, plus k plus 1. I'm here. Next task now it's easy. I will not use this to indicate that we know that from here to here is what I have here to here. True or false? What's the value? This is the value. Abi? So I'll replace from here to here with just what? K over what? K plus 1. So I'll have K over what? K plus 1, right? So I've replaced from here to here as being equal to what? K over what? K plus 1. Next up, I'll have plus 1, this one, over what? K plus 1 into what? K plus 2. Am I correct? Observe, 1 plus 1 is 2. So I have this is now equal to K plus 1 over what? K plus 2. So I have this. Next task, my goal here is to ensure that left hand side is equal to right hand side. Alright, for me, look up please. My LCM here is of course K plus 1 into what? K plus 2. Are we there? If this one cancel this, I'll have this left. K plus 2 times K, I'll have K into what? K plus 2. I have this one plus. If this 2 divide this 2, I'll have 1. 1 times this 1 is of course 1 equal to what? K plus 1 over what? K plus 2. Alright, I have this one. Please expand numerator from here. I'll have what? K squared plus 2k plus 1, right? Over, do not expand this one yet. Repeat it down. K plus 1 into what? K plus 2. Are we there? Equal to what? K plus 1 over K plus 2. I will keep repeating this because there's no way I can simplify this again. This is the least way of simplifying this. I will ensure that what I'm doing here should relate to this. Alright. Looking at my numerator from here. Looking at my numerator, please. Just at the side. So this is volume. Alright, look up please. For me now, look up please. I'm having K squared plus 2k plus 1. If I go back to your SS2, perhaps SS1, if you factorize 1 here, you should be having what? K plus 1 plus into K plus 1. That is, let me just to save time, if I pick out K squared plus 2k plus 1, if I factorize 1, I'll have that. What's my answer? K plus 1 into what? K plus 1. If I factorize 1 using factorization method, or you either use complete square method, you have this K plus 1, K plus 1 as my answer. So here's the concept now. Anyway, I see this now. This I'll put what? K plus 1, K plus 1. So I'll have K plus 1 into what? K plus 1 over this 2. K plus 1 into what there? K plus 1. I have this equal to what? K plus 1 over what? K plus 2. What do you observe? Hold on. This one is 2. So there's a 2 here. Not 1, 2. This will cancel this, Abby. What do I have left there? I have K plus 1 over K plus 2 being equal to K plus 1 over what there? K plus 2. Observe that my left hand side is equal to right hand side. So therefore the mathematical statement is true. So my left hand side is equal to right hand side. So this is my answer to this particular question. If you don't get how I got K squared plus 2k plus 1 to be K plus 1, K plus 1, try to watch my video on quadratic equation under factorization method. Perhaps I'll drop the link to factorization method in the description of this video. So watch that one. It will help you understand how I condense this to become this. All right, let's solve this problem. So see you in the next class.